calculus students. Welcome back to another lesson. This is Mr. Bean, and today we're going to do some graphing of sine and cosine. I know your favorite part, the graphing portions of functions. Now, the graph of a sine and a cosine, they look like waves, and they have a special name to them. They're called sinusoids, and I remember that name because it's kind of like it's a sick dinosaur. You get it with a sinusoid? Okay, so we're going to have lots and lots of applications of these things. They are used all over the place. You've got sound waves, light waves, springs, pendulums, microwaves, even microwaves that look like Mr. Brust's microwave. It's really disgusting. Ocean waves, earthquakes, I mean, all of this stuff, anything that might have any type of repetitive cycle or a wave form to it could be used with sine and cosine graphs. So how in the world are we going to graph these things? What I've done is set up a unit circle with cosine and sine here, and we're going to figure out just a few coordinate points that we can plot on the graph. So let's start off with the cosine graph. Remember, cosine is this should say theta right there. Cosine theta, sine theta. Cosine theta is the x value of the coordinate points all the way around on a unit circle. So if the angle is a 0, then the cosine of 0 is 1. And then if we move up the graph and we get to pi over 2 all the way up here, then the cosine is 0. And then if we continue along, we get to an angle of pi over there at 180 degrees. Cosine is -1. And then we get down to the bottom of the unit circle, an angle 3 pi over 2, we get a 0, and then we come back in a full circle and we get back to the number 1. So let's go ahead and plot those dots. So our input is the angle, the output is the cosine of the angle. So if our angle is a 0, we had a 1, and then we went to pi over 2 and we had 0. Pi was a -1. 3 pi over 2 was back to 0, and then 2 pi, we completed the full circle. So this is one circle going around on the unit circle where it starts at a 1 and then it goes down and up. Now the problem with graphing these, let's repeat the pattern. So then it's going to repeat over here. We could put a dot right there. Now the problem with this is a lot of students, what they'll do wrong is this. They'll say, oh, it just looks like this, like a V, and then back over and over again. Do not do that. You got to be careful here with these graphs, and we're going to round this off. So try and make this as a maximum point that we're going to make a curve almost like a parabola until we get to the x-intercept here, and then but then down here it's almost like a parabola that's opening up. So you have max and mins, all these mountain peaks and valleys that keep going through. Okay, so this is the cycle of cosine theta, cosine graph. Now let's do the sine. So we'll do the same thing with our unit circle, but this time remember the sine value are all of the y values. So if the angle's a 0, the y value is a 0. When we get to the top, it is a 1, and then a 0, and a -1, and a 0. So remember, all I'm doing is I'm just going around the circle looking at the y values at these angle values. So let's go back to our graph and plot these points. So 0, 0, and then at pi over 2 we're up here at the number 1, and then at pi we're back at 0. 3 pi over 2 we're at -1, and at 2 pi we're back at 0. And then if I followed this pattern, if I went back these 2 slots, it would be here for following the pattern there. Okay, so as you can see, if we start off at 0, it's going to go up, down, and then it's going to start over again at the exact same value that we started with. So we have our maximum, goes parabola going down, and then our minimum with kind of like a parabola that's going up. I say parabola, that's not right. I hope you understand that. I'm just doing something that you're used to. All right, there is our value of sine graph. So the key here is that the cosine is going to start off with a maximum. Okay, see this? It starts off with the maximum at the angle of 0. And the sine graph will start off at the origin. Okay, so if you want to try to remember which way these things are going, origin. The cosine has a maximum, the sine is starting off at origin, and if you don't remember that, all you have to do is think, well, what if I put in a 0 at the angle value of 0, or you could think x value of 0, what's the value of cosine? It's 1. What's the value of sine? It's a 0. Okay, you got to get those down fairly strongly. All right, a few more things here to add in. Here we have a standard equation where you're going to have a number here in front of the cosine or the sine, and then a number here in front of the variable. These little coefficients, a and b, and they help us quite a bit with figuring out what the graph looks like. The absolute value of A is what we call the amplitude. It is this fancy way of saying it is how far from a middle equilibrium point the graph is going to go up and down. Okay, so from the middle of the graph, this is called the equilibrium point. That's what this phrase stands for right here. The equilibrium position is the middle, and it's bouncing back and forth from the equilibrium or the balancing point, the middle point. All right, so it's how far up it goes or it's how far down it goes. That's the value of A. Up and down from the middle. All right, what's next? The period. The period is how long it takes for the cycle to repeat or to make one full cycle. So if I'm starting at a maximum point with a cosine graph and I go down and I come back up, that's just done one full cycle, and so the value from here to here is called the period, 2 pi over b. And then the frequency is just the reciprocal of that. The frequency is kind of cool because it has a lot more of the applications when we're talking about things. You've heard of frequency on your radio. The frequency can be thought of as the rate of change because it might be the number of cycles, maybe per minute or per second or per time, whatever we're dealing with. But it's after one angle value, one theta or input value. Okay. Hopefully you are confused. Oh, I know that is confusing. Hopefully this will make some sense, and you're going to have to refer back to this. You're not going to get this on one shot, most of you. So you're going to have to come back and refer to these notes. Make sure you got some good ones there. Let's actually graph some things. Try this out. So, number one, the first thing we have to do is identify what the amplitude is. It is the absolute value of A. So the amplitude here is a 3. And then what is the period? The period is 2 pi over b, and in this case b is a 2. So what does that simplify to? Pi. Period is a pi. And then the frequency does not help us graph it. Okay, we're just practicing it just to write it down and you get the hang of it. It does not help us graph. Amplitude and period are the only things that we really need to help us graph this. Okay, let's try this out. So equilibrium, the middle is just always going to be right down the middle. You don't need to graph this, but it's just right in the middle. That's the equilibrium point. So what we'll do is a sine graph starts at the origin. So we're going to put a dot right there. Now, the period is pi. That means if we go out pi units, it will be repeating. So I'm going to put another dot right there. So what happens in the middle? Remember that sine, okay, don't sketch what I'm about to draw. Sine goes up and down and up. Okay, that's what sine does. So when it's repeating, what I like to do is I put that this is going up and this is going up. Just as a reminder. So what does that mean that's right in the middle of those points? That must be going down. And now you can see there's a maximum and a minimum. So what else do we have going on here? The period was a 3, or the amplitude was a 3. That means from the middle it goes 1, 2, 3. There's a maximum point. And here we go 1, 2, 3. There's a minimum point. Okay, we have the points we need. Now let's just keep this sketching. So every pi over 2, it's going to have an intercept. So pi over 2, pi over 2. So keep going with me here. In fact, you could have just gone and done all the periods. So if I had a period here, I go out 1 pi, it's going up. Another pi, it's going up. Go a pi backwards, it's going up. A pi backwards, it's going up. And then these other ones, it would be going down here. And then we can just count over. So it goes down and up. Down, up, down, up. So see all these? We're going to fill out this whole graph. And my recommendation is start with the maximums or the minimums and just kind of try and sketch. It doesn't need to be perfect unless your teacher's really, really strict about that. Like maybe if you got Mr. Sullivan, he's going to really be on your case for having curved lines that aren't nice and pretty. I don't know. You got to check with your teacher, but as far as I'm concerned, you're doing this with pencil and paper. So just try to make it look good, but maximum. Okay, there we go. So now we've got several cycles on here, and you can see the period is only pi. So every pi, it's repeating a full cycle. All right, let's try another one. Amplitude. So the amplitude's the absolute value of A. So this is going to be just a 2. The period is 2 pi over b, which in this case is a 1/2. So what does that equal? 2 pi over a half, this is 4 pi. You have to remember you have to multiply by the reciprocal to get 4 pi. And then the frequency is 1 over 4 pi. Again, the 1 over 4 pi won't help us graph it, but it does give us some information for application problems. Okay, so cosine. Cosine is the one that starts with a maximum. So the amplitude is a 2. So instead of starting at a normal 1, we start at a 2. But this is tricky. It's a negative 2. So the whole thing flips. So we're going to start down here at a negative 2. So the cosine graph starts with a maximum. Unless it's negative, then it's got to start with a minimum. All right, now it repeats every 4 pi. So let's go out here to 4 pi. 2 pi, 4 pi. It goes off the screen. I'd go all the way off to 4 pi and it would have another minimum point. Well, I can't go that far. And that's okay. Don't freak out about that. If you have this in your practice or the mastery check, you don't need the whole grid to do this. You just have to think halfway to 2 pi, you'll have a maximum. So I'm going to put a maximum with an amplitude of 2. And then that also means if we go this way, there would be a maximum there. Now you can see from negative 2 pi to positive 2 pi, that is 4 pi. And you had a maximum here, so it repeats the cycle. That is perfect. So what do we need left to sketch this? Halfway between the max and mins is an x-intercept. And here, halfway between the max and mins is an x-intercept. And then that's all we need.
So here's a max. Sketch that one down. Here's a maximum. Sketch that one. And a minimum. Oh, that was horrible. Let's try that again. Ooh. Oh, this doesn't look very good. That's horrible. Okay. There is your horribly drawn graph. I guess I could put some arrows on the ends of these things.
All right. Negative 2 cosine 1/2 theta. I want to show you with a graphing calculator how you can graph these, but it is very important to understand this is just for you to check your answers. Let's clear this out. So if you have your calculator, grab it. Zoom 6, okay. And I'm going to plug this thing in here. Sine of 4x. All right, now this is important that you check the mode. This is one of the very few times you have to make sure your mode is correct. It needs to be in degrees, or excuse me, radians. It needs to be radians, not degrees. So let's enter and change it. So in order to make this work correctly, we want radians. Now if I just hit graph on a standard window, Zoom 6, then, okay, it's got all these little lines going on. There's our wave, and that's what we want. But let's clean up this window. Let's say I have the y values. Let's make those -3, +3. That might help us out a little bit. And then we can graph that again. Okay, that looks better. We can see it. But that's a lot of waves going on. So this is where you can change, and you can either manually do this by saying in a -2 pi. If you just say -2 pi to +2 pi, then that will, let me get this one, then that will go just like our grids, -2 pi to 2 pi. Or, let's go back here, this is what's called zoom. And if you look down at option 7, a zoom trig. If you do zoom trig, look at that. Oh my goodness, that is beautiful. It's going right through those tick marks. What kind of window is that? -2 pi, +2 pi, and then this x scale. What's 1.57? That's pi over 2. Okay, so you can also use that, a zoom trig, and that'll jump to a nice window to help you check your graphs. But remember, that's just for checking. On this mastery check, you will not have a calculator, so be prepared to do this with no calculator. So it's only for checking your answers. Number 3, now we have something crazy going on with this +1. The +1 just makes it so that our equilibrium point, the middle, is getting shifted up 1. So instead of being right in the middle here at 0, it's getting shifted up to a y value of y equals 1. That's all you have to really worry about to get this correct. So amplitude is 2, period is 2 pi over b, which is a 1/2, and so then that equals 4 pi. So then our frequency is 1 over 4 pi, and let's start graphing. The sine value. So sine goes through the origin, but since we shifted up 1, we're going to use this red line here, this dashed line. And you might want to put a lightly dashed line on your graph to help you sketch it. Then we're going to go out 4 pi. So I'm going to go all the way to 4 pi, which is totally off my grid. And remember, this is going up, right? So then if I go halfway to a period, it'll be coming back down. You got to think about what the sine graph looks like. And if I go halfway to a period here, that one will also be coming down, and that has a 4 pi period. Going down, 4 pi later, going down. Perfect! Now let's go to halfway between these. I should have a maximum point. amplitude of 2. So I go up 2 from the equilibrium, from the middle. So then here, 1, 2. You go down 2 from the middle. And there is our graph that we can sketch. Very nice. And something like this. Okay, there it is. So I'm going to have you try number 4 on your own. The only thing I'm going to point out is that you might want to rewrite this as -4 cosine of 2x, and then you can say plus 3 on the end if you're not sure about this one. This is just the same thing as saying plus 3 at the end. All right, pause the video now, try this one on your own, and you can see the answer appear in just a minute. And voila! Whoa, that is a lot of waves going on here. It's pretty steep because you got an amplitude of 4, and then the trick here also was shifting it up 3 and making it a negative minimum value because of the -4. So you had to go 1, 2, 3, 4. Started off with a minimum instead of a maximum. It is cosine, so it was going to be either a max or a min. All right. So just take a look at that one. Make sure you've got that one sketched correctly to refer to. Now we're going to create some equations based off of this given information. So this is pretty easy. Amplitude is just the A, no problem. Vertical shift down, we're going to just subtract 4. This is where it gets a little tricky that students struggle with. The period is 4 pi, so what do we do with that? We need to use that and say, okay, so 2 pi over b, that's the period. If 2 pi over b is the period, then it has to equal 4 pi. So that's what you do with this thing. And then you solve. Multiply both sides by b. You get 2 pi equals 4 pi b. And divide both sides by 4 pi. 4 pi. 4 pi. Whoops. Pi. That's a pi. Whatever. And then cancel. Cancel. And this reduces the pi. Cancel. Cancel. And it reduces to 1/2 is equal to b. Now we can create our equation, and the answer is we're going to say y equals, so what is our equation? It's a sine function, it says here. So the amplitude is a 5. We say sine of the b is a 1/2 x. If you want, you could put that in parentheses if you wanted. It doesn't really matter. It's inferred that it's in parentheses. And then we say minus 4 on the outside of this parentheses. Okay, there is our answer. That is the answer to number 5. 5 sine 1/2 x minus 4. Okay, so let's do this again. So again, we're going to use the period. So we'll say 2 pi over b. This represents the period, and we know it has to equal 2/3. So let's solve for b. 2 pi equals, multiply both sides by b, 2/3 b, and then we're going to multiply both sides by 3/2 times 3/2, because then that's going to make a bunch of stuff cancel. 2/3, 3/2 cancel. The 2 and the 2 cancels, and we're left with 6 pi. That is our b. All right, then we're going to go y equals, our a is a 3, so that's our amplitude. 3. And what else? We want sine, of course. This is a sine function. And then we say our b is 6 pi. And then we'll have our x. I guess you could say theta. I'm using x and y. And up 1. There we go. All right, so this is an important step to be able to do because rewind and watch that part. Finding the b is actually the hardest part. The other part's easy because now we're going to take a graph. This is our last example. Now we take a graph and you figure out all of these things that are going on here that we just did on the problem before. So let's find first the equilibrium point. The top is a 2. The bottom is a 4. So halfway in between that, let's see here, 1, 2, 3. It should be -1 is right in the middle. That's the equilibrium point. Why does that matter? Because that means we're going to shift down 1. Okay, that's important. And that also means the amplitude, what's our A going to be? From the middle, we're going 1, 2, 3. The amplitude is a 3. The A is a 3, and it also is positive. We're also doing cosine, so that makes this a little easier. We're doing cosine graphs, so it's starting at a maximum. What else here? We need to figure out what the period is. So if we start here at 0 and we go out and find another period. That's another maximum value. That is 1 period away. It was pi. So we're going to say that the period is equal to pi. Now, how does that help us? It's where we do exactly what we did on the last problem. We say 2 pi over b, which is period, is equal to pi. Solve that thing, and we get 2 pi equals pi b, so 2 equals b. There we go. Now we've got everything we need. So y equals cosine. So we're going to do the a first, 3, and it is positive because we started with a maximum. Cosine graph. Follow the directions carefully on that. And it is 2. Oh, let's do theta this time instead of an x. 2 theta. And then we went down 1 for the equilibrium line, the middle line. And there's our answer. Easy stuff. You just get some practice on this, and it's really not that bad. Man, you finished it. This lesson is done. The only thing I want to remind you is, remember that the cosine graph is going to have a maximum, and the sine graph has a minimum. And the key here is, when you go out a period for the cosine, it's going to have another maximum, but halfway there will be a minimum. But for the sine graph, when you go out a full period, you're going to have another intercept there, and it's going up. So be careful about that. That means halfway there, you're going down. This is the big thing that kids miss, is the middle one on the sine, that it's going the other direction. All right, Mr. Bean signing off here. Rock that mastery check, and I'll see you back in the next lesson.